For this video, I want to talk about what's really important for you to do well on the upcoming exam. Instead of spending too much time on long, complicated problem solving, I want you to focus on what you can do effectively in this short amount of time, what I call image training. At this point, trying to go through every single question might feel overwhelming. So for these last few days before the math exam for IB, I want you to concentrate on mental image training. Visualizing the types of problems, the steps, and the logic behind them. Let me show you what I mean by that. 6, 7. As you guys know, there's a bit of meme about these numbers, but for IB mathematics, they're actually really significant. You want to be getting a 6 or ideally a 7. Especially for AAHL mathematics, there's really no difference in the goal. Everyone should aim for that 7. So let's talk about what we need to do to reach that level. How to get a 6 or 7 in IB mathematics. 6, 7. In education, there's both a teaching aspect and a coaching aspect. What I'm about to share with you is more on the coaching side, especially for those of you about to take the test. The goal of the video is to help you develop that coaching mindset, what to do when you face a tricky problem, and how to open your third eye for solving math questions. Let's see what I mean by that. Okay, I want you to take a look at this May 2025 exam question. When you first see it, there's a lot of things going on. And if you're someone likely to get a 6, you probably read it from top to bottom, thinking, all right, I need to remind myself about compound interest, or I need to be careful with how interest works, and so forth. But when you open your third eye and have done enough image training, you start to see things differently. You pause and think, hold on a sec, I recognize this is pattern. This question is actually about the approximation using the binomial expansion. That's the kind of insight and awareness we are aiming to build throughout this video. The third eye I'm talking about in math is this. To find the answer, you almost need to already know the answer. It might sound a bit strange, but what I mean is this. When you can instantly recognize a question, when something clicks and you remember, oh, I've done a similar type of problem before, that recognition gives you a much higher chance of getting it right. Of course, that kind of insight comes from solving a lot of problems. But at this point, you don't have much time left to go through dozens and dozens of them. If you're solving properly, one good quality problem should take 10 to 20 minutes. And that obviously adds up. So right now, instead of grinding through every question, what you can do is to scan through past problems. Try to recognize the topics and subtopics and key skills you will need to tackle each one. And that's how you train your mathematical third eye. So let's take a look at this example again. When I sit, just by inspection, my third eye tells me, okay, I've seen this kind of question before. This is going to be about approximating a number using binomial expansion. I know I've probably introduced a power of 10 somewhere to make it easier to spot the decimal places. And that makes sense because if I'm dealing with quarterly compounding on yearly interest rate of 4%, I'll be working with something like 1 over 100. So it's quite clear what's going on. So before I even start solving, I already know what I'm going to do. But that doesn't automatically mean you will get the question right. The first half of the problem solving in math is recognizing the clues and knowing what type of problem it is and what idea to use. The second half, however, is your algebraic skill. How fast and accurately you can solve it under the time pressure is the key. So I'm not saying the algebra isn't important. Both parts are essential. You need that quick recognition and solid algebra to solve math problems efficiently and correctly. So let's take a look at this example. So we know for the compound interest, with quarterly compound interest, this is the form that we're expecting. where then the interest rate now becomes 1 over 100. Sorry, so it's 4%. You split that by 4, you get 1%, which is represented as 0.01. So that's great. So now I'm going to do the binomial expansion. Easy peasy, lemon squeezy. And after plug it in, you recognize by plugging the k with 0.01 for the square, for the cubic, for the power 4, it just generates the decimal place that we can naturally add up. And that's how you're going to solve this problem. And as you can see, what you are already trying to foretell by recognizing the problem, you realize how to solve it correctly using your algebraic skills. So the final answer with the multiple of 1,000 will be the following. But as you can see, you might have already gone through our 7-hour revision video. So make sure you're using the resource, our resource, as much as you can. The goal is to prepare smartly and maximize your chance of having already seen a similar question before the test. Okay, ask yourself, what comes to your mind when you see this kind of problem? For me, as soon as I see a theoretical question like this, I know it's not about translating the context or counting outcomes. I don't need to think about what condition or probability I'm given in this story. I'm not solving multi-or problem. Instead, I recognize that this is a really simultaneous equation type of problem. The key is to think, how am I going to convert all these probability symbols? Should I apply the additional rule or maybe another relationship between the probabilities? The way of thinking, identifying the structure before doing the algebra is really, really important. So let's try to quickly remind ourselves. If I see union, that's automatically implying that I'm going to use additional rule. And also the conditional probability is a superstar. We should be able to express this in terms of intersection. And then the probability of A. And also the most common mistake is that students do not prepare the law of total probability. But it's a very, very famous, very, very popular identity to be used in the exam. So please make sure you are well aware of this law of total probability, which we can also express in terms of a conditional probability by the definition of intersection that we have given before. And the complement, etc., etc. And the independence can be expressed as intersection being the product of each event, etc., etc. So as long as you are aware of these laws, the question can be solved using the simultaneous equation. At the end of the day, you really want to describe the probability in terms of a single event or the intersection. Okay, that's very good. Or you could have already be well revised using our video on the YouTube channel. All right, let's have a look at this question. What do you want to see yourself using your third eye? I want you to pause the video and take a look. By inspection, I realize it must be something to do with the geometric sequence. And now I have something about the length and area. And as soon as I'm aware of it, my third eye tells me the following. With the common ratio increasing by 50%, the multiplier is going to be 3 over 2. And the height ratio also increased by 50%, so it's going to be 3 over 2. So the ratio for the area is in fact the square of those two, because it's about the unit. For the length, we have a unit to the power 1. For the area, we have a unit square. So by already recognizing, oh, it's about the length and area, I'm sure if I already have something about the length, I'm going to apply for the area by doing the unit square is already getting you the 50%, first 50% correct for the problem. Or you could have already seen similar question on our revision video so that you can already see, aha, I've seen this one before. It is really important for you to feel that I've seen that problem before in the exam because it gives you the confidence. If you have a confidence when you're solving a problem, there's much higher probability of getting the question correct. All right, I want you to pause the video and ask yourself, what do you see with using your third eye? My third eye tells me, oh, I've got some exponential with the complex number, but I don't know what to do with the base of 3. So I'm sure I gotta use the Euler form. That means you need to be able to convert the 3 in the base of e, which is the part A. And using so, we should be able to convert the Euler form into the cis form using the identity. Let's try to see. So 3 can be exponentiated as e to the power of ln 3. That is great. Now if you now take with the power of I, then I got this e to the power of I times ln 3. And for that part, I know that can be put into the cis form. Using the Euler's formula, now the e to the power of I ln 3 will be cis ln 3. And from here, then question becomes a piece of cake. Because for this one, you can easily see the real part, the imaginary part, to be the cosine of ln 3, and then the sine to be ln 3. And that's how the third eye can help you for solving the problem quickly. So before doing this algebra, we already saw ourselves, oh, okay, complex, exponential, I gotta make the base e. So that comes a little bit of algebra with the exponent, and use of the Euler's formula, Euler's identity in the complex number will give you the cis form correctly, for which then allows me to find the real and imaginary part easily. Or you could have already seen in our revision video where it gives exactly identical example that was posted on our YouTube channel 3 years ago. So I really want you to always increase the chance of having seen the problem with extensive revision. To be honest with you, I think the 7-hour video that I already have on my channel will be the best time to spend if your time is unlimited to revise. That really covers pretty much every aspect of the IB mathematics, and it's really targeted for students who's revising for the math. And please use that hour correctly with the right source of the revision. All right, let's have a look at this example. What does your third eye tells you? Yes. So when I see part A, what comes to my mind is I'm trying to prove the inequality. And as soon as I see the proving inequality and knowing how to distinguish the difference between the solving inequality and proving inequality, the proving technique that comes to my mind is proof by contradiction. So knowing what techniques of proof you're going to be doing is the first half of solving part A. Let's take a look. So this is what we had to prove. So I'm going to do the negation of this to work with the proof by contradiction. All right, so then I'm going to go with the opposite direction. And from here, I'm going to exponentiate with the base of 2 and try to simplify the inequality. And etc. If you not simplify the left-hand side and use the function inverse function property, the second term just becomes n. Now I'm claiming 2n is less than n plus 1 for the positive integer n, for which we know this is a nonsense. And therefore, the initial direction gotta be true. And typically, not always of course, but proving inequality is asking you to use proof by contradiction. And having the third eye of that awareness, oh, I got to do the proof by inequality. Proving the inequality, I would do the contradiction. If you're solving the inequality, it's a different story. For solving the inequality, you might realize it might be something to sketch or do the sign diagram. So knowing how to distinguish those keywords is also very important, which is truly just about the third eye. You already know, we have seen this in our revision video. So just to throw out the fact that our video works, the revision video works, you could have seen this one long time ago and do it very well in the actual exam. All right, what comes to your mind when you see this differential equation problem? Well, for this one, it's relatively easier because they tell you the technique of solving the differential equation. They might not have asked you to use a substitution. That would have been more complicated because it's either really the separation of variable, homogeneous equation, or integrating factor, but they ask you to use a substitution, so it became relatively easier, right? We actually had to make in the form of the derivative is equal to a function of y over x. That's what we had to do. And for that, now the problem becomes a piece of cake. But still, what does your third eye say about the x minus y over x plus y? It's not separable, but it almost looks like a separable. That really tells you the great chance of a homogeneous equation, for which then Your third eye tells you to divide something top and bottom. Let's see what we are supposed to do. So recognizing that it was a homogeneous equation, that it was a homogeneous differential equation is important. Making the right substitution, right derivative, and for the x minus y over x plus y, you want to find the rational function in v. That means y over x. That means on the right-hand side, you would have divided by the x. That would have given you 1 minus y over x, 1 plus y over x, for which then is substitutionable with the v, right? Therefore, then you can begin the whole journey of integrating using the substitution, and it essentially becomes a separable case. So having known that already before solving the problem really improves the chance of getting it correct and solving it fast, because you need to look no more. You might have argued, okay, is it integrating factorable? Well, it might, but we don't have to look at that way because they already pinned down the direction for you. As you can see, our revision video, the 7-hour long, is your third eye. You could have seen the almost identical homogeneous equation problem in our revision video and be confident solving that problem at ease. So I am the third eye for you. Please revise properly and make the good choice before the test. So let's try to work on our third eye. I want you to please pause the video and check yourself. I'm looking at it, right? What am I going to do? The difficult part for the part A, I would argue, is that maybe students was initially thinking or wondering whether it should be done by integration by substitution or by parts, because the question didn't specify. But our third eye says, oh, hold on a sec. It now tells me to decompose cosine x to the power of n as a product of two forms and ask me to integrate. Of course, it got to be integration by parts, right? And also, throughout some exercise and practice you had done at school, you should realize, oh, hold on a sec, I have learned doing the integration by parts many times is actually called the integration by reduction. So being able to come up with a recurrence relation, a sequence, using the integral is called the reduction formula. And this is a very, very famous example. So having done enough practice gives you the awareness of the problem in a high attention skills. So let's see how we're going to actually unfold this problem. So that would definitely ask us to put in integration by parts, even though they didn't specify the technique. So by putting into the antiderivative and derivative form, which one am I going to keep integrating? Which one am I going to keep differentiating? You could have come up with the following form, and using the Pythagorean identity, we can easily express the following integral as desired in the question. And we know that it would be used typically for power 2, power 4, etc. And I will leave you to do the exercise on your own because it's a beautiful question. This is integration by reduction formula. All right. But just to letting you know, doing the right number of the questions or looking at the right quality of resource to revise gives you the awareness in an open aspect where you can be lucky having seen this problem already. You're right, because this integration by reduction formula on working on cosine to the power of n or cosine to the power of 2n is so famous and so popular. We actually have discussed this in one of the YouTube video in our channel to prepare for the paper 3. So just giving you the fact that our revision does definitely work. Okay, so please go through the channel and make sure you watch the right video to enhance the chance of getting 7 at your own leisure. Alright, let's try to use our third eye to attempt this problem. When I see this, I see two things. Oh, they were asking me to sketch the arc cosine x, for which I'm sure you're able to do so using the symmetry by y equal to x, and then the cosine function defined from 0 to pi. No problem. But it was the part B, I believe, which was very interesting, because that sum of arc cosine, and especially the 3 pi over 2, which induces something about the complementary angle, was not seen very often for the exam question. So I believe this is quite challenging problem. But knowing the right skills, right identities, definitely can shorten your time of attempting this problem. If you actually did the compound angle right away with the cosine, things to expand could have been a very, very hideous expansion. But let's see what I mean by that using the simplification. So when we are simplifying this equation, what you could have done is to use this complementary angle identity between the arc-cosine and arc-sine. And using this form, the 3 pi over 2 could have been simplified rather quickly. You would have rearranged the arc-cosine x to the other side, and then use the fact that this is to work with the to work with the complementary angle. As you can see, knowing certain identities to a certain extent can simplify the equations even more and shorten your time to solve the questions greatly. So it's never enough sometimes, and right amount of the revision will get you there. And if you have that, then your third eye will always guide you in the most effective, most efficient way to solve problem. Because for the exam preparation, at the end of the day, you have to be aware of the time pressure. Or you already know the sum of arc-cosine and using this reference angle or complementary angle were typically seen in our revision video. So please go through and have a go. Alright, let's take a look at another May 2025 exam question. You already know, by having done some exercise in the previous questions that we have done today, that we have discussed, now I'm again proving the inequality. But now this question actually got simpler because they dictate the method. It says proof by contradiction. And yes, typically proving the inequality would involve contradiction. You already know. So therefore, we're going to do the negation of the statement and try to derive the contradiction, the absurdity, and solve the problem. Right? And from here, I will let you try to do it because it's a very nice example that I don't want to blow this up, right? I don't want to blow your chance to solve a very interesting problem. But I'm just letting you know, a few years ago for our revision video, you can already tell that there was an example that we already discussed, right? So please, again, I'm just reminding you the best thing to do to revise in this remaining time of the exam is to go through our video once again thoroughly, exhaustively, and increase the chance of getting 7. Let's take a look at the next question. This typical exam question on the polynomial with the complex number, with the complex roots, but reciprocating the roots, what would it do on the coefficient of the polynomial has appeared at least 3 times for the past 3 years. So it's never enough to emphasize the importance of this problem. And what is more challenging especially for part D, is to find the coefficient. And for that, they didn't ask you what substitution you should make. And for this one, in your third eye tells you the following. Oh, hold on a sec. I've seen this one exam question quite often actually for the past few years. You should be already aware of that. And by looking at now, we're trying to find the solution in terms of Z1, Z2, Z3, Z4, but now they reciprocate it. So for my omega, which is a new variable, should be the reciprocal of Z. Simple as that, right? So having that awareness, having the third eye tells you to make the substitution rather quickly, because it's usually the question that doesn't tell you what substitution you should make, because that's the key aspect, key deductive thinking to solve this problem. If doing so, then you can expand and then again multiply by the omega to the power 4 on both sides, so that you get this following polynomial, which will have the solution as 1 over Z1, 1 over Z2, etc., etc. This has appeared before, so I'm just letting you know, being able to solve this at ease with your third eye should have come from your own practice. Or where can it have come from? What do you think? Exactly. In our revision video, like 2 or 3 years ago, we already have talked about what does it mean when you have a solution and you reciprocate. And we have to find the other polynomial using the right substitution, and then the problem can be solved rather quickly. So make sure we always try to follow, okay? We always try to follow the revision material on our YouTube channel and try to amplify the chance of getting 6 or 7. All right. There are many limit problems these days on the question number 9 on paper 1, so please pay attention. It's the reason I think they're trying to emphasize on the limit problem with trigonometry is whether you can do the L'Hopital, or whether you already know enough number of identities to simplify things. So when you look at it, it says determine the value of the limit. What we could have done is to rush through using L'Hopital, or you could have already said some trig identity that you can plug it in. Pause the video. Please tell me, what identity does this remind you? By looking at it with my third eye, it tells me the sine x over 1 minus cosine x is in fact the half angle of cotangent, right? And knowing that identity already can solve this problem within split second. Let me quickly show you. So how do we derive the half angle of cotangent is the following. I'm just trying to use double angle of cosine. In this case, I'm trying to let the x to be 2 times x over 2. So this is just double angle version of the sine x. And as you can see, the x times sine x over 1 minus cosine x can be substituted as the following. Then what common factor do you see? We see the 2 sine x over 2, right? So that would cancel out. And then we have cosine x over 2 over sine x over 2, which is essentially the cotangent x over 2. As you can see, the given identity, given function, can be simplified rather quickly. And now, by expressing the cotangent as a 1 over tangent, it gives you another famous limit identity. Remember, the fundamental limit of trigonometry, there are 3 versions of it. Sine x over x, tangent x over x, arctangent x over x. When you send x approaches to 0, they all become 1, right? So knowing that identity of looking at this form, I realize the x over 2 over tangent x over 2 essentially will go to 1 as x goes to 0. Therefore, because of that fundamental limit of trigonometry, our limit will now converge to who? 2. That's it. So I don't need L'Hopital. In fact, knowing that trigonometric identity can solve this question really, really quickly. Just letting you know, what we want to do is to simplify quickly, solve the problem as efficiently as possible. So emphasis on the limit these days on the question number 9. But I feel like they haven't been putting the hard, challenging combinatorial problem on the question number 9. Maybe it's coming in November, because for the past 1 or 2 years, they've been putting limit problems only on the question number 9. So I do expect some challenging combinatorial problem in the question number 9 on paper 1. So let's see how it's going to turn out in this November. Mark my word. But that's what we expect. Okay? But as you can see, hey, right? I believe this was a May 2024 exam question on the limit. And what I tried to show here is to use no L'Hopital, only the trig identities to solve the problem. And yes, trig identities, more the merrier if you know some. Or the fundamental limit of trigonometry. If you know them well, you can solve the problems rather quickly, especially with the limit problem. All right, so the final tips for you. What I want you to do now, right? Now you have paper 1 on Monday. How many more days? How many more hours? We don't have much. So what you need is more image training. I want you to scan through the problems and see yourself whether you can have your third eyes activated and be able to come up with the right equations with the right number of lines. I don't want you to write extended essay for solving a problem. Try to be as efficient as possible so that you minimize your time on the problem. You must already know the answer. Well, I'm not saying that you should know the value, but you already should know the right path to take. Ask yourself whether you have seen such problem before. That's always a good start. And where can you see it? On our YouTube channel. That already covers the first 50%. However, it does not get you 7 right away. You need to make sure you attempt them. It's not bystander sports. Mathematics is not a bystander sports. You need to be able to actually get your hands dirty. You solve them by your hands and then manage to get the correct answer. Okay, so that was the coaching aspect of the video. I didn't want to make the video too long because, first of all, I don't think many people watch if it's too long. And also, by now, I already have abundance of resources on our YouTube channel that you can watch and gain the insight that you need for the exam preparation, and you already, I have proven it numerous times that the revision video certainly works. I have a playlist of going through exam from 2017 to up to now, how correctly predicting my material and videos has been. So please benefit yourself also from learning with the video. Okay, so that's pretty much it for me today. Wish you all the best for the November exam, and open your third eye. You can do it. Let's try to get 6 or 7. See you next time.